Welcome back to the Algebra 2 series. Today we're continuing from the first mathematical models example, and we come across this one, which is a distance example. Find the ordered pair for the point on the graph of 4 minus x squared that is closest to the point 5, 1. We've done some of these before, but nothing that was this involved, where we have the graph of a parabola, and just from transformations we can see that the graph should look something like this and has a y-intercept up here at 4. And we're talking about a point that's out here somewhere around, say, 5, 1. And the question is, what is the value of x, or where's the location that is closest? Now, if I were to just estimate, I'd probably say it's somewhere around here. That looks about as close as it's going to get. Notice that if I back this up a bit, if you go back to here, this would be farther, and then this would be also farther, but then it would be closer, it seems, over here, perhaps, and then farther away again. So this is a very complicated problem. But again, I think it's somewhere over here. I don't think it's directly across from 5. It looks like it's a little bit less. But one thing we've learned so far from these functions is that the ordered pair for the point on the graph is no longer xy. It's x f of x, or x 4 minus x squared. And what that does for us is it puts the ordered pair in terms of x, or in other words, in one variable only. So here now we can start with our distance formula. We have been working on the distance formula in our section here, and we recall x2 minus x1 quantity squared, and then plus y2 minus y1 quantity squared, all under a radical. If that's the case, I'm going to use those 2 points to work this out. The distance is equal to, and this will just take a little bit of algebra here, the x2 being, and I'll just use this first term up here as my x2. So x minus 5, that's going to be squared. And then the y2 is this guy, 4 minus x squared minus 1, and that's all squared. Now it looks like it's just a lot of algebra here. Working this out, we end up with x squared minus 10x plus 25. Before I multiply this second side, I notice that 4 minus 1 is just 3, so I'm going to rewrite this in my head as 3 minus x squared before I FOIL that out. So this will be plus. This would be 9 minus 6x squared plus x to the 4th, working that part out. Combining our like terms, we end up with the following polynomial underneath. I'm going to put the x to the 4th first. I have a minus 6x squared and a plus x squared, or minus 5x squared. And then I have minus 10x, and 25 plus 9 is 34. That is my distance function. And the question is, how could we make that a minimum? What is the smallest number that that's going to be? We can't really do this one in our head. We can't calculate this out. So at this point, we're going to need to bring in a little bit of technical assistance from our fancy calculator here. So what I've done is I've programmed our function into the TI-84. As you can see, we have in the Y screen x to the 4th minus 5x squared minus 10x plus 34, and there's a square root in front of it, which means we're taking the square root of the whole thing. And just for this one, for this example, I'm going to graph by zooming to standard, which should give us the overall graph. Now keep in mind that the x values are the actual x values, the y values are the actual distances. Let me switch over to the large screen. This looks a little bit messy, but in this case now, I would like to calculate where this minimum is. So we're going to create a little triangle here and a little triangle here, and then it's going to lock right on to that spot, and we're concerned with the x value for that one. So let's see if I can get this ink layer out of the way. There we go. So let's go ahead and do that. The way we do that is to do second and calculate. And this time we're going to use a minimum. Minimum. Notice that if I use my right and left arrow keys, I can get close there with the left bound and then with the right bound. Those are the two triangles I spoke of a moment ago. Enter a third time. And what we're concerned with is this number right down at the bottom here. And it looks like it's a 1.9455. We'll round that to 4 decimal places. 1.9455. That's the number I was looking for. Now, also, this number, 3.1537, that's the actual distance. So if we wanted to find out the minimum distance, we could actually calculate that. But the question in the problem does not ask for the minimum distance. It asks for the ordered pair on the original function. So we will use this x value, 1.9455. And let's bring this down here. So we know that that's going to be the minimum, 1.9455. That's the x value that created that. Well, let's go back to the beginning and see what this is talking about. Notice that that's the x value right there, 1.9455. And if we plug that number into here, we will have the second half of that ordered pair, 4 minus 1.9455 quantity squared, and that would be the y value of the ordered pair. So the point we're looking for has that ordered pair, and I'm going to just write it in its ugliest form here, 1.9455, comma, 4 minus 1.9455. And that's, did I do that right? Yeah, that's quantity squared. That quantity is squared. That is the nasty little ordered pair for the point closest to the point 5, 1. Isn't math mysterious? Oh boy.